To this example, we would like to find this integral. Okay, this is actually it is very easy to find this polynomial function. Okay, for someone you can derive the polynomial function, derive the integral by hand. Okay, analytically. Okay, you can integrate, right? Okay, but for this time, we may create a table. It's very easy to create like this. Okay, this is the segment x, and then this is fx for the first and the last term, right? Okay, this is just for the first and the last. Okay, and this is for fx for any point. Okay, actually you can create this the same column. It's up to you. Okay. Okay, right now we subdivide the limit of integration. Actually, okay, I may insert a little bit. We have the limit of integration A and B, right? And how many segments that we would like to subdivide? Okay, that is it's maybe N and H. Okay. So for this case, A is equal to what? A is equal to 0, right? And B equal to 2, right? And we would like to subdivide it into 10 segments. Okay, so then S is become what? S is equal to B minus A, right? Divided by N. Okay, so then we have S equal to 0.2, right? Okay, so if we have 10 segments, we should have 11 nodes. That is, we may define it from 0 to 10. Okay, so for the first is from the limit of integration, we have starting point is 0, right? And then is equal to what? Is equal to this point plus h. Okay. Sorry. Okay, we have this. And then we have x for each point like this. Are you all right? And the function is very easy. Function is what? Function is 2x power 3, okay, minus 5x power 2, okay, plus 3x, okay, plus 1. Already done, right? And the last point is maybe over here. And for this point, it should be the same, but we have to change this to be what? This cell instead. Are you all right? And then, okay, I recommend you to use at least 6 digits for integration. But because you use Excel, right, you may use more than 6 digits. Okay. The Excel is maybe double precision, that is have 15 digits. So for this case, we use just at least 6 digits. Okay. So after we complete it like this, so then what is that? We find the solution, right? The formula, the trapezoidal rule formula is what? We have this formula, right? Okay, so then what is it? We find sum up of this column. It become 1 plus 3 equal to 4, right? And then we sum up this column. We have 11.4, the summation of this column, right? Okay, so then what is the integral? What is the integral? Integral is equal to what? Is equal to h over 2, right?
h over 2
H over 2 multiplied with
the fx0
fx0 plus
fx
xn, right?
10.
That is
Yes.
that is cell, this cell, right? Okay,
Yeah.
that is this cell. Okay, and then plus 2,
Plus
right? Plus
yes.
2. Okay, that is actually we have to be in the bracket, right? Plus 2
Yes.
multiplied
Plus
with the summation
the
of
summation
fx.
of yes.
It should be this cell, right? And then
Yes.
we have the result. Maybe like this. Are you all right? Okay. What do you think? Can we accept this solution? Okay. Can we accept this solution? We may. It's up to us. Okay. Comparison with the exact one. The exact solution is what? To this case, when we determine the exact solution, the exact solution is 2.6. Okay. So what do you think? Can you accept it?
Yes.
Yes. If you say that, if your problem, if you can accept, that's okay, that's all right. Okay. If not, how can we do?
We can increase the number of partition and we can increase n.
Okay, you can increase n, right? What do you think? How many n that you will use?
20.
20? Okay, that's fine. So then s is become 0.1, right? Okay, so then we have to increase the table also, right? So then it should be 20, right? And then it should be like this. And this term, it just has to be like this. Okay, and we have to delete it. Okay. Right? Am I correct? And then for another point, do the same thing, right? Okay. So now, how can we do? Sum up this table, right? And it is the same. Okay. Are you all right? We have these two values. So what's next? I's become what? I's become what? I is
H
equal
by
to
2.
S over 2. S is over here. Divided by 2, right? Okay. This, okay, plus 2 times this. Okay, what do you think? Better, right? Are you alright? You understand?
Yes.
Okay, but you see that trapezoidal rule has a limit, right? You have to subdivide the interval a lot, right? We have to subdivide. You see that we increase the segment already to be 20 from 10 to 20, but the solution is still, I think it's maybe increase the precise of the solution a little bit, right? If we compare the error, that is it's maybe this is the exact one, right? This exact one, okay? So then this is a previous one. So what is the percent error? Okay, it's 0.5. 0.5% error, right? And this should be become 0.125. Okay. If we would like to reduce the precision, reduce the error less than this, we have to subdivide the segment more than 20, right? Okay. That actually, when you write the computer program, is easy to do. Okay, because it's you can create the loop. It's more than 20 times for complete the solution, and it's very easy to do that. Okay, but you see that it's maybe half another technique that is maybe better than trapezoidal rule. Okay, so then right now, do you understand trapezoidal rule? Okay, that I will stop this clip before.